This video will talk you through using chart problems to help organize a word problem. I will start with number 9 on page 124, and the problem states, Brian earns twice as much each week as a tutor than he does pumping gas. So if I let the gas job represent the X, then he earns twice as much tutoring. So his weekly wages will be comprised of 2x plus x, or 3x in this problem. And then we're comparing this to his sister. So his sister earns 1/4 as much as Brian does as a tutor. So I really don't have information about tutoring pumping gas, but I will say that her weekly wages, I will go ahead and say she earns 1/4 as much as he does at his tutoring job in a single week. And then they give me a condition that links the amounts together. Brian's total weekly wages are $150 more than that of his sister. So my equation math model would be Brian would equal his sister plus 150. And then I look at my last column and I make substitutions into my model equation. Brian gets replaced with 3x, sister gets replaced with 1/4 times 2x, and then the plus 150 just gets copied down. 1/4 times 2x is really just 1/2 x. And since I know that I'm going to be in a world of halves, I'm going to go ahead and say 6/2x equaling 1/2 x plus 150. And then I'll move over here just to give myself some space. So that means that I now have 5/2 x equaling 150. X is 60. So that means that Brian earns $60 pumping gas, $120 tutoring, and I'm able to answer anything that's asked about the question from that point on. Let's move down now and look at number 13 together. Number 13. And here I have two people that are selling cars. So I have data for the month of March and the month of April. And when I read the problem, in March, Rodney sold twice as many cars as Greg. So if I let Greg represent my variable, he's X. Rodney sold twice as many in the month of March. And then I'm comparing April to March. So as I read on, in April, Rodney sold 5 fewer than he did in March. So his April sales would be his March sales minus 5. And then the other person sold 3 more than they did in March. So his April sales will be his March sales plus 3. And then the problem states that the April sales are the same for both men. So Rodney would equal Greg in the month of April. And then I make my substitutions. And it becomes fairly simple to solve from that point on. The next problem to look at on the video would be numbers 16 and 17, and they're very similar. So I'm just going to do 16 on the video and let you all set up 17 on your own. I didn't provide charts for these, but here in number 16, I'm comparing the Eiffel Tower and the Washington Monument. And I'm going to go ahead and say one column is their measurement now, and then the other column, they give you a conditional statement. I'll call that an if. So if this condition holds, then I would have a different relationship. So here's my chart. And now I'm going to read the problem. The Eiffel Tower is 497 feet taller than the Washington Monument. So if I let the monument be represented by X, the Eiffel Tower would be X plus 497. And now I have this conditional if statement. So the problem states that if each monument were 58 feet shorter, and I'm going to go ahead and copy, so here's my Eiffel Tower, and here's my Washington Monument. And then my if conditional comes in stating that if each were 58 shorter, which means I'm going to subtract 58 from both. So I'm going to take my if column because the problem states that under this if condition of 58 feet shorter, then my math model, the Eiffel Tower, is twice as tall as the Washington Monument. So the chart helps arrange. I'm given my initial now relationship, I'll call it, And then they change it by putting a condition on it. I'll just call this my if condition. If each monument were 58 feet shorter, so I take my now condition, my now algebraic expression, and I subtract 58 from each expression. And then they give me a relationship about the heights based on the if condition. So my math model would be that the Eiffel Tower equals 2 times the Washington Monument. So I would take the information from my if column and I would slip it into my math model, make my substitutions in my math model there, and solve this. And I will let you all get through that on your own. Number 17 is the same type of problem, just discussing different players, different numbers, and I will let you take the model that I've set up here and do number 17 by yourself. Let's look at number 20. So number 20 is 2 teams, and they're meeting for a track meet twice a year. I have East and I have West. So the cross-country teams of East and West run against each other twice each fall. At meet number 1, East's score was 2/3 of West. So if I let West be my variable for meet number 1, East was 2/3 of West in meet number 1. And then in the second meet, so in meet number 2, I'm comparing what happened in meet number 1, and I'm giving a condition, and I will change colors. East's score increased by 7 points, so East went up by 7, and West decreased by 7. So this is meet number 2. In the second meet, West's score was 3 less than East. So I have sort of a problem. It's not really that hard, but I need to think about it for a second. So I've got East and I've got West, and I'm just doing a little scratch paper analysis here for meet number 2. In the second meet, West scored 3 less than East. So that means if East scored 10, West scored 7. If East scored 9, West scored 6. If East scored 5, West scored 2. If East scored X, then West would have scored X minus 3. So if I want to set up an equality here, if I want to set up a math model to make some, to set something up that I could solve, I could say that East minus 3 would equal West, because then their scores would be the same. Or I could say, had West scored 3 more points, then they would be equal to East. So West plus 3 more points, then they would have had the same score as East. So choose the math model that you're the most comfortable with, either this version or this version, it doesn't matter. But then you take your algebraic expressions from your meet number 2 column and you make substitutions, and you can go, I'll call this A, you can go into equation A or equation B. Both alternatives are correct, but I think that the challenge in this problem is seeing the setup for either equation A or equation B. And I like my scratch paper thinking here because it's very straightforward and it's simple for me to see, if it's just simple to see the 3-point difference. But when I'm trying to set up the math model, here's my model, when I'm setting up my model for solving, I do need to make sure that I'm truly setting up 2 expressions that are equal to each other. And I will let you take that from there on your own.